All right, so today we're going to be talking about solving expressions with complex numbers. So meaning we're going to have complex numbers, which is what we talked about at the beginning of the year, where we had real numbers and non-real numbers, or in this case, imaginary numbers. I know you guys are really excited to learn about this. Imaginary numbers now on top of the numbers that you already know that are real. So if you need to, a quick refresher might be to go back into your notes to the very beginning where we had that chart with real numbers and non-real numbers. So to begin with today, it is important to know that I squared is equal to -1. And then on that note of I squared being equal to -1, it is also important to know that I by itself is equal to the square root of -1. So this works out because what you can do is you can say, if you squared this, like it is squared over here, this square root and the square cancel out. We learned about this earlier in the week. So then that just leaves you with that -1, like over here. So that's how that all works out. But in the end, those are the two things that you need to know. You really need to write down the word that's in black. The other thing to know, that I is called the imaginary unit. Imaginary unit. So with that imaginary unit, when we're talking about pure imaginary numbers, so the pure versus unpure, these are square roots. Square roots of negative real numbers. So this means we still have our real numbers that we're dealing with, that we learned about at the beginning of the year and that we've been using throughout this. But on top of those real numbers that we've learned about, we're also going to be talking about taking the square roots of basically negative numbers, of all those negative numbers that you know about. So examples of these are like 3i, so 3 times I, because they're right next to each other, and when they're right next to each other, it means they're being multiplied. -5i, and I times the square root of 2. So then going into our examples, when we have the square root of -18, what this is saying is that, let me change that color to black, is that we have a -1 in here. So it's like saying -1 times 18 underneath the square root. Then what we're going to do is we're going to take those factor trees we talked about before, where if we take the factor tree of this, we have like 9 and 2, and then we have 3, 3, 2, and 2. Then we can take that factor tree and say, well, what we actually have is -1 times 3 squared times 2. So pulling that 3 squared from over here and that 2 from here. So then if we were to split this up, it's like saying, okay, we have our -1, our square root of that -1 times our square root of 3 squared times our square root of 2. So then once we're here, we can say, oh wait, we know that the square root of this -1, or the square root of -1 here, is equal to that I. So we can say I times, well, what's 3 squared, the square root of that? Well, it's just 3 times the square root of 2. So then if we were to combine this all together, we end up with 3 times I times the square root of 2. So this is like saying, okay, we have the square root of a negative number. We know that negative number can be written as 1 times 125 times x to the 5th. So then with this example here, we can still split it up and say we have our square root of -1 times the square root of 125 times the square root of x to the 5th. So then what this is basically doing is it's saying, okay, we have this -1 here. We already know that that is going to be equal to I. Then we have this square root of 125, and if you plug a square root of 125 into your calculator, you end up with a decimal. That is not what we're looking for. What we're looking for is for it to be a regular whole number. However, with 125, we can't split it up that way. What we can do, though, with our factor tree is say, okay, so into 125 goes 25 and 5, which also goes 5 and 5. If we have here this 5 and 5, that gives us a 5 squared. And then if we then also include our extra square root of 5 that's still left over because we have 3 5s here, if we include that over there, then we can say that those cancel out. But we still have to worry about this here. So then with that, we can say, well, if we had x to the 4th, that's divisible by 2, and then we would have 1x left over because x plus x to the 4th would give you x to the 5th. So then after all of this splitting up here, we can then say we have our I. We also have times our 5 because this canceled out to just 5, times our square root of 5 because that was left over, times if we took the square root of x to the 4th, that's just going to give us x squared, times our leftover square root of x. So then combining all of these together, you end up with 5 from here, x squared I times the square root of 5x. And then that ends up being your final answer. Over to example 3, when we're looking at this one, these ones get a little bit simpler. We can say, okay, we have our -2i times our 7i. If we multiply -2 and 7, we get -14. If we multiply I and I, we get I squared. And what did we say we knew about I squared? All the way up here, we said I squared equals -1. So then knowing that we have -14 times a -1, that just gives us a regular positive 14 as our final answer. Our next one as well is a little bit simpler. If we're looking at this one, we already know that we can pull out, we can pull out that -1, which will give us I times our 10. This is a positive 10 now, because we took out that negative, times I to the times square root of 15. So once we're here, we combine together our i's. We get I squared times the square root of 10 times 5, or 10 times 15, which gives us 150. And then if we do our factor tree of 150, we end up with 25 and 6, which gives us 5 and 5, which gives us 3 and 2. And then we can say I squared 5i squared because the square root times 6. Then because we know that I squared is equal to -1, we can say -5 times the square root of 6. On to our next one, second to last one here. So with this one, we have this 3x squared plus 48. Here with this one, we are going to start by doing like a one-step equation. We want to get x by itself. So if we want to get x by itself there, we can say 3x squared equals 48, -48, because we like added we took 48 away from both sides. So then after that, we would divide by 3, divide by 3. Those cancel. We get x squared is equal to negative 16. Then with that, we would take the square root of both sides so that we could end up getting x by itself with those canceling. And then that tells us we have x equals the square root of negative 16. We know we don't like negatives underneath our radical symbol. So then that means we'll change that negative into an I, which means x equals 4i. Also looking at this, no, I'll skip that part. Okay, on to the last one here. I'm going to erase a little bit of this information up here. Okay, what we can do is we can take this 6 here and this 1 here. They don't have i's attached to them. And we can say, all right, so we have 6 plus 1. And then we can also say, let's add on. Now our other ones have this negative 4i and this 3i. We can say negative 4 plus 3, so taking those front coefficients and then attaching an I there. Once we're to this part, we can simplify, saying 6 plus 1 gives us 7, plus negative 4 plus 3 gives us negative 1 times I, which then in the end will give us 7 minus I, because negative 1 times I will give us a minus I. And then this will be our final answer.